Hello everyone. Well, I totally messed up with my oscilloscope on my last video regarding this receiver. I thought I was running both off the same power supply, but I wasn't. This is the transmitter is running off the Arduino, and the Arduino's power coming through the USB, whereas this receiver is actually running off 5 volts from my bench supply, and I had this connected to the same ground as this one, and that's why it gave me that stupid signal. I wasn't sure why I was getting it. So this video is just a follow-up to correct my cock-up in the first one with the oscilloscope. Everything else is right in the video. It's just what you actually see on the oscilloscope that's wrong. Now I've got the ground on the right pin. The reason for this is my project is going to be using 3.3 volts, and I tend to forget the voltages, and so they're separate because this is going to have to be powered differently than what it is. And that's what led to my mistake. It's a newbie mistake, but you know, we all make them. So yeah, let me just show you what the signal should look like. Where is it? There we go. So yeah, that's what it should look like, guys. It should be a nice square wave, and you can see that a certain duty, at certain duty cycles it doesn't come out like it tends to, the upper amp doesn't quite separate the signals, so that there is working out. I tell you what, I'll leave the two things here that plugged in right, and I just want to go over just a few tests. The one with it still applies that. Hang on. So it still applies whether you're using this one without the big coil, or the one, this one's got the ceramic inductor on, or whether you've got the big coil of wire as the inductor. That makes no difference. That tiny thing is exactly the same as the big coil of wire. So yeah, all that's correct. And the repair's correct. So it's just that I made a really big mistake with my oscilloscope, and I just wanted to clear things up a bit. I've left it in there. I haven't edited the video. I don't care, basically. So here's what it should look like. And what I'm going to do is I'm just going to make that bigger, because we don't actually need to look at everything behind here. We're just looking at the oscilloscope now, and so just make it so big, and then I can still see this thing. We're also going to need the Arduino, because I'm going to change things on there, so I'll just move that. Actually, I'll just move that down a touch, so I can click on things. There we go. Get that up there. Oh, actually, no, I had it down there. If I have it down there and then I can move that up, then I can see that it's compiling as well. Then when I change the thing, yeah, there, that's making it all clear. So we can see now that we're at well, it was at 10 hertz there. So when it's getting a good signal, I'm sending 10 hertz and it's receiving 10 hertz. So it's all hunky-dory now. Let's have a look at my code. Oh, I'll tell you what, if you want to actually type this out, or if you want the code, just ask and I'll put it up on my Google, what was it, Google Drive or whatever they call them. So basically these are just some presets. It's simple really, and then we have the loop at the bottom, and I've put two different loops, so you can either have this what we're seeing now where it adjusts, or you can have a preset where it'll stick to a preset. So if you want to do some tuning, and to switch between these two, it uses this fixed duty cycle definition. So if you've got it commented out there, look, so I've got this commented out, it will use this code, and if you uncomment that, it will use just this bit of code here at the bottom. And so you can switch between the two by just commenting this out or uncommenting it. So we'll leave it at the adjustable one to start with, and so at the moment it's running at 10 Hertz. I just want to show you that if you send signals too slow, it will pick up this bit of interference. So shall I get my big hand? Yeah, big pointer. Yeah, so you can see where when it gets to a low duty cycle you get interference, and when it gets to a high duty cycle you'll get interferences again as well. There, look, and let it go to a high interference. 10 Hertz is a good speed to actually watch what's happening there. You can get to see the interference when you get to a high duty cycle. So if you go too slow with your signals, so if we knock this down to 1, save that and upload it. At 1 Hertz, I mean, we're going really slow, so you can actually see it, and so what will happen is you will see where we get all the interference like this. So there you can see that we're only going at 1 Hertz. Hang on, let me just zoom out a touch. There. No, go a bit slower. There we go. So you can see here, see here that the changes is we're changing really slow, and you can see it's really bad now. Is at a duty cycle really small. Until that duty cycle increases, the interference will go. But we're actually sending a signal too slow, and so you're getting a load of garbage. So basically, you're better off going above the garbage speed. So we are 10. I reckon 10 is about the slowest to get a clean signal received. So once that compiles, we'll be back to the normal speed. Just wait for it to upload. See, it's uploading, and then it's uploaded, and then if we increase the we can see that, and so I mean, this is just a program I've done just to experiment and test things with. So if we can actually go up to 50 Hertz, so it's going to go 5 times faster than that. So you see how it's actually increasing duty, so you can examine how good the signal is. It's going to go really fast. So let's go that. Alright, it's just about to upload. Yeah, so let's just take a good little look at it. There, you can see it going really fast now. But you can you still get that garbage at sort of over 90% duty and under 10% duty. You're better off in between So it's just, and just to show you that you can actually send signals really quick. I mean the frequency is in the megahertz, so there's no reason why we can't go that, but we're not actually going to be able to see it. But what I'll do is I'll increase that to 500 hertz, save that and upload it. It just speeds things up, that's all. But I thought I'd just show you, and you know what sort of signal. Basically this video is just because I screwed it up last time. So let's just zoom in on that. There, you see we can't see it, but you can still send a signal, and it's still getting quite a good up and down square wave, as long as we don't do the duty. So what I can do is, what we'll do is we'll put the duty at 50 hertz instead of it scanning from sort of 0 to 100. If I stick it at 100 hertz, so if we just uncomment that now and save that, what we should see is actually two good square waves. He says, fingers crossed. Actually uploads. There we go. Right. Well, we're not actually. Oh, well, you can see that it's got at that speed. We're getting quite a pause, a bit of lag, and obviously when it comes down, there's a bit of lag there. So I wonder if I change the. Let's try put the trigger onto the blue side. Hang about. Let me just close that. Trigger menu. There we go. Let's have a look at that now. Yeah. Now let's just move the trigger down a touch. Oh, too far. There. What have I got it set on? Yeah, I must have it set on raise. But yeah, you can see there's a bit of lag there. Right, let's just drop it down to 50. Oh, I've covered up my. Yeah, that shows it better. Let's just see if we can get a full wave in. Right, yeah, so when we're getting a full wave in, it doesn't look too bad, but when I open it up, we can actually see, I mean, we're talking microseconds, so I don't think we're really worried about that. Yeah. Nah. Talking out my ass again. Right. So, yeah. I just wanted to do this video so you can see what it looks like, and it should look like, and experiment. And like I say, if you want this code, well, I mean, you can just copy it from that screen. Well, I'll tell you what. Make sure you can see it. Right. So there's the first bit. And move it down to there, and move it down to the loop. That will show first bit of loop. So you just do a screenshot, and then bob it, do another screenshot. There you go. And how big did I have it? It was about that. Can I still read it? Yeah. Yeah. That's the reason why I use this instead of. I still use this to upload and everything. It does a hell of a lot in the background for you. It does the Arduino IDE, and if you're using an IDE Arduino IDE compatible module, then it's the easiest ways to upload things, and you don't have to do a lot of code. So there we go. Right, yeah, that was just to correct my cock up, guys. So yeah, that's what the signal should look like when you've got the ground lead to the correct ground. Okay guys, catch you later.